All right, so I thought it might be helpful to run through question number 5 here, given we lost class today, just so you can kind of hear a little bit more of an explanation than just looking at the solutions, okay? So let's read the problem, and then we can maybe discuss how to think about A and B. So it says, the rate at which water flows out of a pipe, again, notice rate, and when you're reading this, you should be thinking of keywords, right? Rate is a keyword here. The rate at which water flows out of a pipe in gallons per hour, okay, is given by a differentiable function. If it's differentiable, we also know it's continuous. Function r of time t. The table above shows the rate as measured every 3 hours for a 24-hour period. All right, so for part A, it says use a midpoint Riemann sum with 4 subdivisions. That means 4 rectangles. Okay, so we have 4 rectangles of equal length to approximate you don't necessarily need to know what that is yet. Basically approximate the area under the curve from 0 to 24, okay? So again, we'll talk more about this next class in terms of what this means. But for right now, just interpret that as, right, area under the curve from 0 to 24. It will not show up on the quiz. That notation will not show up on the quiz. But if you're doing any of these practice problems, that's what it means. Area under the curve from 0 to 12. Using correct units, explain the meaning of your answers in terms of water flow. Okay, so let's start with this part A, midpoint Riemann sum. So that means the height of each triangle is going to be the midpoint of each rectangle. Sorry, did I say triangle? The height of each rectangle, okay, is going to go through the midpoint of each rectangle. So it says 4 subdivisions, so that means 4 rectangles. So if I want to know basically how wide each rectangle is, I'm just going to think of this as terms of change in x. Change in x for me is just going to mean like the width of your rectangle. If I have a total of 24 hours and I want 4 subdivisions, my change in x, or my width of my rectangle, is just going to be 24 over 4, okay, or 6. So that means each rectangle is going to have a width of 6. So if I'm looking at this chart up here, there's one rectangle, 0 to 6. Then I have another rectangle, 6 to 12. Another rectangle, 12 to 18. And my last rectangle, 18 to 24, okay? And if you're thinking, all right, my height needs to be the midpoint of each rectangle, it's kind of nice that each one of those rectangles has a point perfectly in the middle, right? So my heights of my rectangles are going to be occurring at 3, at 9, at 15, and at 21. Those are the midpoints of all my rectangles. We're going to try to do the Riemann sums without drawing this out, okay? So when you think about it, we have 4 rectangles each, okay, with a width of 6. So let's write this out, okay? I have 4 rectangles, so R4 is going to be equal. Now, some of you may be comfortable factoring out the width out of each term. I'm not going to do that here, but if you're comfortable doing that, feel free to. So my first rectangle is going to have a width of 6, and its height, okay, is going to be the midpoint of the first rectangle from 0 to 6. The midpoint would be at 3, and I can see that the height of that rectangle at that midpoint would be 10.4. So it'd be 6 times 10.4. That would give me the area of my first rectangle, plus width again is 6. Now I'm at my middle rectangle, okay, or one of my 2 middle rectangles. The midpoint of that rectangle from 6 to 12 is 9, and its height there is 11.2, plus 6 again. The midpoint of my third rectangle is 11.3, plus another width of 6, times the height of my last rectangle is going to be at 21, which is 10.2, which, when we equal all this out, comes out to 258.6 gallons. Okay? Again, if you wanted to draw this out, okay, I don't know if I don't want to spend the time drawing it out right now, but right, the height of your rectangles would be at the exact height of where the graph would be at 3, 9, 15, and 21, okay? So in terms of how you calculate, it's not much different than the left or right Riemann sums, okay? But you should be comfortable with finding the height in terms of the midpoint of each rectangle, okay? So it's 258.6 gallons is what my Riemann sums calculation or estimation comes back as. And it says, using correct units, explain the meaning of your answer in terms of water flow. All right. So again, what we're given, we're finding the area under the curve of R of t, which is gallons per hour. So finding the area under that curve would give me total gallons. Okay. So let's maybe write this out. This represents, okay. And since Riemann sums is an approximation, it's not the actual area under the curve, I'm going to say approximate. So this represents the approximate, okay, approximate total gallons, okay, that flowed out of the pipe, that flowed out of the pipe. And this is where you need to really be specific. Is it just for the history of the pipe? Is it over some specific time interval? As you can see, it's from the time interval 0 hours to 24 hours. So we want to be specific. This represents the approximate total gallons that flowed out of the pipe from time t equals 0 to t equals 24. Done. Okay, so be very specific, okay? Riemann sums, there's a lot of problems that ask us to calculate the Riemann sums that you can practice. So if you're feeling a little bit unsure about that, practice that. I know it can be tricky at first, but in addition to just calculating those Riemann sums, make sure you really understand what it is asking you, okay? Or excuse me, what it is telling you. Okay, what does that area under the curve tell us? All right, then part B. Okay, this is what some of us struggled on the exam, was how do we put our answers here in English. It says, is there some time t from 0 to 24 such that r prime of t equals 0? Okay, justify your answer. So r prime of t is asking for the derivative of the function we're given. Okay, so is there such a place that the derivative, or the tangent line, between 0 and 24 equals 0? This should scream mean value theorem to you. I hope it does. Okay, mean value theorem is what we're thinking here. So let's think about how to write a mean value theorem problem. Okay, we underline at the beginning this differentiable. Okay, that wasn't there by accident. Differentiable means you can take the derivative, it's continuous. It also means the mean value theorem applies. Okay, if we look at the slope between 0 and 24, we really don't even need to do out the calculation. The height, okay, at 0 is 9.6. The height at 24 is 9.6. Okay, let's actually do out the calculations just so you don't yell at me. If we do the calculation of 9.6 minus 9.6 over 24 minus 0, that's calculating the slope of the secant line. That gives me 0. Okay, so given that the secant slope is 0, must there be a tangent slope of 0 in between 0 and 24? Yes, only because we know the function is differentiable and thus continuous. So in our explanation, we need to mention that. All right, so let's go through how we would say this. This is a format you can use every time. So for those of you who might be struggling, look at how I'm writing this. Look at the pattern and see if that's something you can duplicate on your own on some of these other mean value theorem and IVT questions. All right, so let's write this out. So the first thing I want to say is get the prerequisites of using the mean value theorem out of the way. If you want to use mean value theorem, what must be true? It must be differentiable and continuous. So let's say that right off the bat. If you don't say that, you can't use the MVT. So given, okay, and let's be specific. Let's use the name of the function, r of t. So given r of t is differentiable and thus continuous. It doesn't say continuous. We're kind of making that determination, right? We're understanding that if it says it's differentiable, that means it's also continuous, okay? And where is it differentiable and continuous? I don't know if it's over the whole function, but I do know from 0 to 24, the data points we have, it is. So let's say given r of t is differentiable and thus continuous, okay, over the interval 0 to 24, okay, and the secant slope is 0, and they can see from our work up here that we calculated it. So again, let's think about what we've said so far. We started with the prerequisite that the function is differentiable and continuous. We are then saying what the secant slope is. If you don't mention the secant slope, you can't prove the tangent slope is the same thing. So given it's the secant slope is 0, okay, so we have to, so since we said the function is continuous and differentiable over the interval from 0 to 4, and the secant slope is 0 over that interval, okay, then what can we say? Then the MVT guarantees at least one value. At least one value. Okay. At least one value t. Again, where t is between 24. Okay. Doesn't mean there could be some t value outside of 24. It has to be in 0 to 24. Okay, where, and again, let's be specific, where r prime of t, that's what the question specifically asks for, where r prime of t equals 0. So again, I said this before the midterm, and I'll repeat it again, where you can use specific notation. So notice they asked the question about r prime of t. In my answer, I have r prime of t. Okay, in my question it asked about an interval, I certainly used intervals here. So where you can repeat the same notation in specific references, do the same thing. You can't go wrong. Once you start going into crazy English and long explanations, trying to describe something that can be described in a notation, you get yourself in trouble, okay? So those are two good parts to questions, I think, that are really helpful. Again, like everything else in this class, understanding more so than mechanics are gonna what leads you to success. So if you're having some trouble, come find me tomorrow or Thursday, and I'm happy to walk through this with you, talk it through with you, and make sure you feel good about it.